Alright, today the program we are watching has a very fitting title. That's because it is called The Gift of Green. That's what we're watching today. The Gift of Green by Robert Flaherty. Publication date 1946. The Gift of Green. I'm not quite sure what this is about. The Gift of Green, it must be about plants, but I'm not quite sure exactly what it's about. So let's dive in, right? Let's watch The Gift of Green here on the Green Channel. Oh, wow. Okay, so hang on. Very, very immediate sound cue here. But even before the sound kicked in, we got this one frame saying we are from the New York Botanical Garden. So we kind of lost a little bit of the intro to this video, but we can still see the title card a little. It says the New York Botanical Garden presents The Gift of Green. So this is actually by the New York Botanical Garden. That's interesting because I'm pretty sure I've been to the New York Botanical Garden. I've been to the botanical gardens in the Bronx. I'm not quite sure if that's the New York Botanical Gardens or if there's like another one in like Albany somewhere. But the Bronx Botanical Gardens is a fantastic botanical garden. So I'm curious if that's where this was all filmed. That would actually be very enjoyable. If I actually end up recognizing the botanical garden in this, that would be amazing. Technical advisor, Dr. William Robbins, director of the New York Botanical Garden. Okay. It makes sense that you would have the director of the botanical garden as your technical advisor for something like this. What exactly this is, I'm not quite sure, but it makes sense to have Robin Williams, or William Robbins with us. So this was written and directed by David Flaherty. Narration consult is Dr. E.E. Naylor, and then the narration is David Allen. That's a position I've never seen in one of these before, the narration consult. So that must have been like the director for the narrator, right? Like the guy who listens to the narrator and tells him like how to enunciate certain things. That's all I can really imagine that position would be. And then the editor was Helen Van Dongen. That's probably like the first time I've actually seen a woman in the credits to one of these things. And she's the editor. That's funny because there's a whole thing like women make really good editors.
It's a green world we live in, and lucky we are that it is. Yet how
lucky that we are. So we are obviously talking about plants. I'm glad I got at least that correct.
few of us realize the significance of the plants which make it green.
Few of us realize the significance of the... Hang on, what is that? What did you just say? First off, I'm going to call it. It's chlorophyll, all right? Like, that's what makes plants green. I hate to spoil it for all you guys. I already know the answer. It's chlorophyll. Or really, is it the chloroplasts? Well, isn't the chlorophyll in the chloroplasts? I think so.
In this color of nature, symbol of youth and growth, the green...
In this color of nature, the symbol of youth and growth. See, I don't really know if green is a color of youth, you know? Like, I feel like pink and, like, light blue, those are, like, the youth colors, you know? I don't think there's a green that would ever make me think of youth. But, you know, what do I know? Maybe back during this time, green was a color of youth. That would be interesting to learn.
Green plants, from lowly grass to lofty trees, hold the key to life on Earth. The beauty of this green we take for granted.
I guess it is a symbol of growth, though, not only in, like, money, but, like, yeah, obviously in terms of plants as well. Things that are green do grow. So, you know what, fine. I'll accept that statement.
Hold the key to life on Earth. The beauty of this green we take for granted.
You know what's funny is that, like, they keep talking about literally the color green, but, like, the film on this program is just not preserved well enough for us to really pick up on the green that very well.
The pine trees of northern woods, the wind-shaped cypresses.
This is a cool tree. I feel like this tree is like a famous tree almost. Like, I feel like I've seen this, like, outline of a tree before. Am I wrong? Like, can somebody look up if this tree, can somebody find this tree for me? That might be one of the wildest goose chases I've ever sent my audience on. It's just finding this specific tree. But it is a really, like, awesome shape for a tree. Like, this looks like a cartoon drawing. I mean, it's a silhouette, so you don't really get to see the detail anyway. But, like, this is a bizarre shape for a tree.
Cypresses. The giant forests of snow-clad west.
Wow, that was a good shot. The fog through the redwood forest. I think this is a redwood. Yeah, this has to be a redwood forest. This is a really cool shot. The camera wasn't so good at capturing all the detail of the shot, but like you can tell the artistry's there in this shot. Like you can see the sun rays coming through the fog or the mist of the forest. If this was filmed on a modern camera in this day and age, like this would be a really awesome shot. It still is. You just can't really appreciate it that much anymore. But I can. That's what we're here for, is because I can appreciate these shots.
And slopes.
What mountains are these? Are these the Rockies?
The bright, lush growth of warmer places. Palms of tropic lands, in kind and number endless.
So now we're just talking about like different sorts of plants. I wonder if we're going to like focus up at any point and actually like get to a subject. Like, are we just going to be talking about the color green this whole time? Like, I really hope not. As much fun as that does sound, like I want more information than like plants are green, you know?
Trees to give beauty. Trees to bear fruit.
What tree? What tree is this? What fruit is this? Like, I don't even know. These look like kiwis almost. I don't want to claim that. These also look like something that you would farm not in this part of the world. I guess that's all I can say. They almost look like Brussels sprouts. They're not Brussels sprouts, but they look like Brussels sprouts.
Trees to shelter and shade. How much we owe to the trees. To all.
You know what's funny? I always say this in the old programs, right? Like, I wonder if this person is still alive. I wonder how old these kids are. But, like, these trees probably are still alive. Like, of all the things we've watched, these trees, maybe not, they could have been cut down, but, like, there is a very good chance that these trees are still alive. I think that's the funniest part, is really, like, I don't know, that's just how time passes, I guess. Like, trees do just live longer than humans do, really.
Green plants, large and small. Green plants.
Oh man, I also got to keep in mind what I'm going to make the thumbnail, because like it's so hard to convey the idea of just green. So like I got to keep an eye out for like a very like visually green image, if you guys understand what I'm saying. Like I need an image that even in black and white would say green for the thumbnail.
Green leaves such as these, through a wonder-working substance.
Oh, is this a croton? That's interesting. See, these aren't even green. I mean, they are a little, but like they're mostly like red and yellow.
Substance they contain, trap and...
Oh, because this was filmed at the Botanical Gardens. I'm starting to realize, like, okay, so these are all exhibits at the Botanical Gardens. That's why we're filming them. That's funny. Oh, you know what? I should go to the Botanical Gardens in the Bronx and look for some of these trees now. Like, it's possible. Like, I can do my own research here.
And store the energy of the sun for man use. Without the green plants, we could not live. By a process peculiar to themselves.
Without the green plants, we could not live. Like, that's a bit of an understatement, honestly. Like, without the green plants, we never even would have evolved, you know? Like, that's more accurate in my mind. Like, like, our existence is predicated on the existence of green, leafy green plants being there for, like, billions of years before us as well.
They build within themselves something...
Oh, no way. I literally have one of these plants right behind me. That's so funny, but I gotta go back real quick. I want to hear what he has to say. I mishear what the narrator says so often that I really want to hear what he has to say.
They build within themselves something vital to all existence.
They build within themselves something vital to all existence. Is it chlorophyll? I think it's chlorophyll.
For this process, 2 building materials are needed.
All right, so we're talking about photosynthesis now, it seems. So what are the 2 materials that are necessary for photosynthesis? Well, you could honestly give a lot, right? Like you need light, you need chlorophyll in the leaves, but you also need water and light and like nutrients and carbon and oxygen. I don't know exactly what the 2 specific ingredients for photosynthesis are. Like, is it chlorophyll and sunlight? Like, that's what I would say. If this were a test in middle school, I'd say chlorophyll and sunlight, but I don't know.
Is water.
Water. See, I think I said water a second ago, but it's like, I mean, I guess that goes without saying, you know, like everything needs water. Like you can't, I don't know, like, yeah, that's an easy one. That's a low-hanging fruit that that I failed to pick, I guess.
The water particle, or molecule, contains 2 atoms of hydrogen.
Dang, that's so funny. You can hear like the audio switch over, like they were recording and then they recorded the next day or something. Like the audio quality and characteristics actually changed. Like you can tell this is a different recording day or something. They must have changed the mic, or they must have changed like the gain on the mic or something. Like you can tell something went wonky with the audio right here. That's so funny. I love seeing mistakes like that because I've made mistakes like that. I still make mistakes like that in my Atlas Pro videos today. So like, it's funny to see that for the entire time we've been making like educational programs, we've been having the same audio issues. I love that camaraderie I'm feeling with Helen right now. Helen is the person who made that editing choice. So Helen knows my pain. I know Helen's pain.
And 1 of oxygen. The other building material is air.
The other building material is air. So yeah, I would have gotten that middle school photosynthesis question wrong, I guess. So it's water and air, not chlorophyll and sunlight. I should probably look so dumb saying that now. Oh, whatever.
Not all parts of the air, but only colorless, invisible carbon dioxide, of which the air contains.
All right, well, at least I also said carbon dioxide too. These are all things that I did list. I didn't know which ones they would go with. You know what? I did know that you needed water and air for photosynthesis. That wasn't my final answer, I guess.
Contains hardly more than a trace. We are all familiar with carbon dioxide. It is the gas returned to the air when animals breathe and when fuels burn.
I like how they said we're all familiar with carbon dioxide. We're literally learning about photosynthesis for like the first time ever right now, but you're just assuming that we know what carbon dioxide is, you know, like, and you have to imagine like a child in a middle school is watching this and like, I don't know, a child from what, 1946, like an immediately post-war child learning about photosynthesis is just assumed to know what carbon dioxide is, which I don't know, I guess maybe they did, I don't know. That feels like an advanced level of knowledge to expect from your audience at this point. I expect it from you guys though. You all should know what carbon dioxide is.
The carbon dioxide molecule contains 1 atom of carbon.
Dang, I love these little animations too. These are a little bit more simple than most of the other animations we've talked about on this channel, but like even these are so fun. They're just like, they are good at illustrating exactly what they're trying to. Like I just like the visual here, right? Like imagine if I made a visual like this on Atlas Pro, just like a picture of an atom and the text saying carbon dioxide, you know, like it's not as engaging visually as maybe modern YouTube educational content is, but like it gets the idea across. It still contains all the same information. That's the point, I think.
Carbon and 2 of oxygen. Oxygen as a free element makes it possible for us to breathe.
Yeah, oxygen O2, that's what we're seeing right here.
We cannot see oxygen in the air.
Oh man, are we gonna see oxygen bubbles coming off the sea plants? I have a whole aquarium over there too that I see this as well.
But if we expose a water plant to sunlight,
oxygen. Yeah, I love seeing this sort of stuff. Like the actual like biochemical processes like taking place right before your eyes. Like seeing the production of oxygen through these leaves is just like, that's actually witnessing like life taking place, if you ask me.
Oxygen off by the plant rises to the surface in bubbles.
Those are a lot of bubbles though. This is a very productive plant if that's the case.
Oxygen,
like my plants do not produce that much oxygen. That much I know.
However, is not one of the plant's building materials, but a byproduct of its work.
This is a really cool shot though. Again, like the photography here. Shout out. What was the photographer's name? We looked at the credits, so we know the photographer's name. Shout out to him for getting these shots. Again, like you must be shooting this through an aquarium glass pane, right? Like so you're trying to get as close as possible with your macro lens or whatever you're using, but obviously there's a limit to how close you can get because it's inside of an aquarium. So I have to imagine this must have taken a little bit of preparation, a little bit of setting up and figuring things out. Or they just filmed it with an underwater camera, which would have made it easier, but I don't think they did that. If I feel the distance between us and this plant right now, I feel like there's a pane of glass right here.
If we cut off the sunlight, the bubbles slow down and stop.
That's actually really cool too. I love seeing these like real life, like kinetic demonstrations. Like this is even more interesting than like any of the physics stuff we've watched so far. Just seeing that stream of oxygen bubbles cease from emptying out of this plant stem. Like that's life. Like that's actual life for you, you know?
Without the sun, this activity ends.
Yeah, I got bad news for you guys in these plants. These plants have definitely not survived to this day. These plants probably lasted like another few weeks after the filming of this.
Most plants have tiny hair-like rootlets, difficult to see when a plant is pulled from the ground. But when seeds are germinated in a covered dish...
Again, it's like some pretty impressive footage, you know, like you obviously have to prepare to get footage like this. You can't just like say, oh, today we're making Gift of Green, like let's get some seeds together. Like you have to plant these seeds weeks in advance to get these shots that you want.
These delicate white hairs are easily visible.
These are, again, really good shots of illustrating what we're talking about. Like the little fine, they call them hairs, so I'm going to call them hairs too. These little fine, delicate, like hairs or cilia, maybe you'd call them cilia, of these roots. Like the fact that you get to see them through this camera, like incredible shot right here. Again, another macro shot, I have to imagine. Like you must have changed your lens or like zoomed in on your lens at the very least in order to get these shots. Like this is an average shot to get with a camera that.
These root hairs, here greatly...
Oh, root hairs. So they are just going with the term root hairs. All right, nobody in the comments yell at me for also calling them that then, please. Like I have a very strong feeling that we don't call them root hairs anymore, but I don't have the proper term, or at least I'm not confident enough in my term. So I'm just going to use their term instead. Root hairs. Interesting. So now we have a diagram of these root hairs. Fun. Let's see what these root hairs are all about.
Magnified, are important to the life of plants. Through them, water is drawn from the soil and into the root.
Drawn from the soil. So what they're not mentioning is the relationships that these root hairs form with mycelia or fungi in the soil. I think that's a bit advanced for this program, but I just want you all to know that I am thinking about that as well.
Through the root and up the stem.
Again, this is an impressive animation still. Like not only are all these little dots moving up the plant stem, but also the camera's moving, you know? Like you're doing all these animations while the animation plate itself is moving. It's just, it's complex.
The water passes into the veins of the green leaf.
Yeah, look at this leaf animation too. It's probably on a loop. That's the thing. That's how most of these early animations worked, is they would just make a loop cycle. It's like 3 or 4 different shots that they just cycle throughout to make it look like something's constantly moving. Even still, that's a lot of work that somebody had to do. And again, on a computer, that's a very easy thing to do. That's really just a copy and paste sort of deal. But here, you actually have to put the plates over and over again. You know, like there's no shortcuts when you do it for real. Like you actually have to do it physically, which is just, I'm trying to appreciate all that, all right? That's what I'm saying. I'm trying to appreciate the amount of times you had to swap out all these plates to get this shot to look, you know, fluid.
A greatly enlarged view.
Oh, this is cool. This is like the stomata, right? This is like the underside of the leaf. This is a crazy little diagram. This is fun. This is a lot of fun, though.
View of the leaf's underside reveals part of its intricate structure.
Is this, there's no way this is an actual shot, right? Like this has to be an illustration, right? Like I'm gonna look so dumb for asking that. Yeah, this is totally an illustration. I don't know why. The shading of these little cells is what got me. It's like, this is too fine a detail. It's too well shaded to be not like a really high piece of work right here.
Here among the epidermal cells are minute openings.
Epidermal cells, minute openings. Are we going to get the term stomata? Am I pulling that out of my ass, or is that actually what these are called? Let's see. Am I right or am I wrong?
Or pores, called stomata.
There we go. The pores called stomata. Thank you, high school biology. Well, I guess I also learned that in college, but like, that's where it all came from.
There are thousands of these stomata in 1 square inch of leaf surface.
Thousands of stomata in 1 square inch. That's crazy because I didn't think it was actually that many. I thought there were like not a lot of stomata on a leaf. I don't know what a lot of stomata versus not a lot of stomata even looks like, so I don't know.
Now let's look inside the leaf.
Oh man, this is such good, not even animations, but diagrams. That's really the more important part. Like whatever animations are taking place, those are cool, but like the actual science illustration that we're looking at, like that's what's important about this. Like this is a very good illustration of a cell wall.
Exposed to direct sunlight is the upper skin, or epidermis.
Dang, we even call it the epidermis on plants? That's interesting. Like, not bark or whatever. I mean, obviously we call it bark too, but like, it's weird that like, this is my epidermis and plants also have an epidermis. I don't know, like, it makes sense, but it weirds me out at the same time.
Under this transparent surface is a layer of cells like palisades.
Like palisades. See, that's interesting because like, that's assuming that a child in middle school knows what a palisade is. Like I'm trying to think what they even mean by palisade, because I've told you guys I live next to a geographic feature called the Palisades, which are like these rock walls that have been carved by glaciers. But I don't think that's what they're talking about here. I think they're referring to like the actual meaning of a palisade, like a spear that you surround your like village in or something. Like I think that's what a palisade is supposed to be. So I think that's what they're actually referring to here when they call this the palisade layer, is like tall standing sticks or spears that are pointing. I don't know. I honestly don't know what the connotation of palisade is here. This is also not the term that I learned for this. I don't know exactly what we're talking about here. Is this like the phospholipids? Is that what this is, or is this something else? If they say phospholipid in this, I'm getting a pat on the back, that's for sure.
In this palisade layer is concentrated most of the leaf's green coloring matter.
Oh, okay. Are these the chloroplasts then? This might be the chloroplasts. And then the chlorophyll is inside of them. Or is it vice versa? I can't remember if I'm getting that mixed up or not.
The small green bodies here faintly seen are called chloroplasts.
Okay, so these are the chloroplasts. Okay, throw out the phospholipid layer. That's animal cells. These are chloroplasts.
Under the palisade layer...
So the palisades are the chloroplasts. Why wouldn't they just say that, you know? Like, what is the palisade? What does that even mean? You know, like, just call them the chloroplasts. I don't know. So hang on. So is the epidermis transparent then? Does sunlight just go straight through the epidermis to the palisade layer or the chloroplasts? That's interesting. I mean, I guess that makes sense, obviously, but it's just like... it infers or it implies that the epidermis is like so perfectly transparent that it does not affect the amount of light received at the palisade layer.
Is a spongy storage.
And then the spongy layer. I haven't even been paying attention. All right, so now we're talking about the spongy layer. I really don't know what this stuff is.
Storage layer, just above the lower epidermis. Here we see in cross-section a stoma or pore.
A stoma. Oh yeah. So a stomata, that's like plural. So stoma is a singular stomata. That's funny. I don't know. That's just like a terminology thing that I wasn't thinking about either.
Through thousands of such pores, air, with its particles of carbon dioxide gas, enters the plant and makes its way into every living cell.
You know what's so funny about these animations is like, even though they're so like minimal in what's moving or what's even happening, like the idea is still conveyed perfectly. Like you can still see the air molecules entering the leaf and going into the rest of it and going into the spongy layer or whatever, you know, like even though this might not be the most engaging or visually stimulating animation, it is the information is all still there.
Through these same pores, part of the water drawn from the soil escapes into the air. Enough water is retained, however, to permeate every cell of the leaf.
A couple of audio glubs right there. That must have been making Helen worried a little bit there.
The carbon dioxide and the water finally reach the living chloroplasts. Here they are.
What a funny little edit. Again, like we were zooming in through the animation just to cut to another animation anyway. It's just like, I guess it's implying that we're getting closer. It's like, yes, they're trying to speak. Helen is trying her hardest to tell us the story of what we're doing in this while doing it. It's like she's trying to tell us that we're zooming in by zooming in herself. Or I don't even know if Helen really would have been the one, because she's the editor, but she's not the animator. So she might have just been, so it might have been the animator's choice to do that. To zoom in, to immediately, well, I guess it was Helen's choice to immediately cut to another shot, but I guess that might have been the plan all along anyways.
Here they are. Many
This is the chloroplast, or are these the chlorophyll inside of the chloroplast? I think that's what we're finally getting to.
many molecules of carbon dioxide and of water inside a chloroplast.
Inside a chloroplast. All right, so we are looking at the water and carbon dioxide inside a chloroplast right now. There's so many terms that I could drop just to like make you guys sure that I know what we're talking about here. But are we going to talk about like the electron transport chain or the Krebs cycle or anything? Like, are we going to get into that? Probably not. Definitely not in this program, but I wonder if we'll ever learn about that on this channel.
Here, too, is the key to an everyday wonder.
That feels a little bit too advanced for something like this, but I'm hopeful. If we even get a mention of the Krebs cycle, I'll do a backflip.
It is called chlorophyll, and chlorophyll is what makes plants green. Chlorophyll has the power to trap
Oh, we finally got chlorophyll mentioned, though. That's not another term that I was making up. That's a real thing.
the sunlight and harness its life-giving energy.
See, so you do need sunlight. I wasn't wrong.
Sunlight, air, water, and chlorophyll.
Okay, hang on. So I'm just going to highlight the fact that he just gave 4 necessary ingredients for photosynthesis. He said sunlight, air, water, and chlorophyll. So technically, the answer I gave, that's like half credit to say the least. Even though I did list all of those, like the answer I gave, I don't know. My ego's a little hurt by getting that question wrong at the beginning. So I'm just trying to rescue myself a little here.
With these, the plant's work is performed. The process is called photosynthesis.
Dude, I love how it spins too. Like, what a funny little animation choice too. Like, just make it spin. Like, they wanted to show that they were all going faster. Because we know about heat, its nature, and its transfer, we know that the more heated something gets, the more active, the faster it moves. So I like that that's what they're trying to convey with the spinning of all these molecules. Not quite accurate, if I would say, but like pretty much conveying information still.
Meaning putting together or building with the aid of light. More oxygen is...
Imagine this is what's happening inside of cells, though. There's just like crazy spinning, like 1,000 revolutions a second. Honestly, that would be pretty cool. Honestly, I don't even know if there isn't spinning. Like, I don't even want to confidently say spinning does not occur inside the chloroplast. But this is just not how I pictured a chloroplast producing energy.
produced by the process, then is used by the plant. This oxygen is...
I do love the little pieces of molecules flying out of this thing, though. Like that again, like there's so much like character in these old animations. Like they're trying to illustrate every little thing, but they don't have the skills to like really make it visible. Like you can barely see the little molecules flying out of the cell, but if you're paying attention, you can see them.
is returned to the air and is the oxygen we breathe, without which we would die of suffocation. And what is built from these simple materials? Something not at all simple. By complex chemical reactions,
I mean, I guess they did mention complex chemical reactions. That's not a full mentioning of the Krebs cycle. Or what are the other cycles? There's like, oh man, there's so many cycles in photosynthesis. I don't even know if Krebs is right. I think that might be for metabolism. But there is metabolism in plant cells too. Maybe I'm confusing myself now.
the plant makes a complicated molecule. And bound in this molecule is the energy of the sun.
Is this glucose? Oh man, I feel like I shouldn't be guessing. Like I feel like I should either be confidently saying answers or not questioning things. But like, is this glucose? I'm pretty sure this is glucose.
This complex molecule, formed of simpler molecules joined together, represents a food.
A food? What type of food though? Is it glucose? Oh man, I can't believe I forgot what the product of photosynthesis actually is. I'm pretty sure it's sugar. I'm pretty sure it's glucose, but I'm not sure now. I'm not confident now.
A direct source of energy for living things. It takes an infinite number of molecules precisely arranged
Dang, they're really not going to tell us what the molecule is, though? Like, what the actual product of photosynthesis is? I'm pretty sure it's glucose, now that I'm thinking about it. I'm pretty sure I'm right about that. No, they're not saying it, you know?
to make just one crystal of this food,
One crystal. Okay, so, like, maybe they are going to say it.
common sugar.
Sugar. Okay, it is glucose. Thank you. I was starting to get worried there for a second. I was starting to think that I was just making myself look like a fool.
This crystal is sucrose.
Oh, sucrose. All right, that makes more sense. All right, sucrose, not glucose. I'll accept that. It might be fructose too. Like the plants makes different sorts of sugars.
Though other sugars, glucose and fructose.
Oh, okay. Okay, there we go. He said glucose and fructose as well. Then you know what? That deserves a pat on the back. I listed all the sugars, or all of the commonly known plant sugars, at least. Somebody in the comments is going to let me know of the other sugars plants can also produce.
Though other sugars, glucose and fructose, were probably made first in the plant.
Oh, okay, so he didn't say that much.
What happens to the sugars which the...
Oh man, now we're getting more time-lapse footage. If you guys have stuck with this channel long enough, you'll be familiar with time-lapse footage of plants. Hang on, when was that made though? This is made in 46. This might actually be older time-lapse footage than Life of a Plant. I don't remember when that was released though, but this might be older time-lapse plant footage.
The sun's energy...
And look, these are ferns, right? These look like they're ferns at least.
...green plants make. The sun's energy contained in this food is required first of all for the plant's growth, for the formation of new pots.
Yeah, this is very interesting. This is like impressive plant time-lapse footage. What I like about it is that it's a different plant than what we watched in that Life of a Plant video. These are ferns. We were watching pea plants, I think, in that video. So it's cool getting to see not only this sort of thing again, but for a different plant as well. Are they ferns? They look like ferns, but also not really.
The growth of a fern...
Okay, there you go, it's a fern.
The opening of flowers.
That's another pat on the back.
The opening of flowers, processes covering days in nature, demonstrate...
Oh, dang, this is cool too, getting to see the time-lapse of the flowers blooming. See, this is like, again, more impressive time-lapse footage right here.
Demonstrate the energy plants derive from the food they make.
And this is like a very interesting time-lapse, just because of the way the flowers themselves like wiggle around. Yeah, see, we didn't get anything like this in that last Life of a Plant video. We didn't get like a flower opening up. Like that's really cool time-lapse footage as well. This is the sort of music that always gets copyrighted. Like, I'm going to leave it in. I want you guys to enjoy, like, the original music and everything of these programs. So I leave it in even if it's going to get copyrighted, but listening to it now, it's just like, oh no, please, please don't. Now we're watching orchids, right? That looked like an orchid. Whoa, that was cool. This is actually like really enjoyable time-lapse footage. This must have been so exciting to get in the time, right? Imagine you're 1946 and you're getting to watch this sort of stuff. Like, I know this isn't really that cool nowadays. Like, nowadays we have so much crazier time-lapse footage, but for the time, this is like really cool.
Some of this energy is used by the plant to build its architectural structure, like the veins which hold up the broad, thin surface of a leaf.
Like the veins. I feel like I should know what these veins are actually called. Oh man, I can't think of the term off the top of my head, but I know there's a better term to be calling these than veins.
The woody trunk of a tree supports the crown of leaves and branches. Some of the plant sugar is converted into starch, cellulose, and lignin. Many vegetables store converted sugar as starch, chemically a close relative of sugar.
It's interesting too. I mean, I guess this corn isn't green, but this is like... I guess we are just talking about plants generally now. Like, I don't know. I thought there would be like more of a focus. I guess this is fine. It's just like, it's funny. We're really just talking about everything green under the sun now. But that is cool for like kids to learn, right? That like the sugars that the plant cells make go into making our foods taste good. I feel like that's like a little bit of a mind-blowing realization for some kids.
Converted into starch, cellulose, and lignin. Many vegetables store converted sugar as starch, chemically a close relative of sugar.
I'm trying to think of what the chemical composition of starch is. I can't come up with it. I'm pretty sure glucose is what, C6H12O6, right? Like, what's starch? What is starch, like the same numbers but in a different format, or what's starch compared to glucose? I really hope some of you are impressed with me recalling the chemical formula for glucose right there.
Some plants.
That's more impressive than any of you realize for me.
In some plants, sugar, after undergoing chemical changes, is stored as fats or oils. The coconut palm stores in its seed an oil used in foods.
Oh, the date palm oil? Yeah, I feel like now we farm date palms for this oil specifically.
In soaps and various other products.
That is interesting. I feel like I never would have discovered oil on my own. Like date palm oil, like how do you squeeze a seed until the oil comes out? You know, like I guess I get it. It's just that really is something I never would have come up with on my own.
The edible fruit of the olive tree is rich in oil.
Can somebody tell me what an olive off the tree tastes like? Are they the same or are they different? Like I've never had an off the tree olive before.
And so is the avocado.
Oh wow, the avocado. That's actually really funny. I did not expect them to mention the avocado. But for me, the avocado seems like more recent than this. Like obviously they've been around for like thousands of years now, but like I feel like we only started like eating them or selling them in grocery stores like within my lifetime. But I guess not. I guess people were familiar with avocados all the way back then as well. Were they still putting these on toast? Like, what was the Americans' use of an avocado back then? Like, what were we putting avocado on? Like, now I'm so curious. Like, how long have we been making avocado toast?
The plant sugar.
Mind you, I don't actually eat avocado toast. I like making guacamole to put on my quesadillas, but like, whatever. I still like avocados.
Combines with nitrogen, phosphorus, and other minerals from the soil to produce the important proteins.
Oh, those were green beans, weren't they? And what are these? I can't tell. These are like chickpeas almost.
Peas and beans are excellent sources of plant proteins. Other combinations derive...
Hang on, ascorbic acid, is that what that was? Ascorbic, let me go back. Yeah, ascorbic acid, vitamin C, that's funny.
Other combinations derived from sugar give man his vitamins. Not only the well-known leafy vegetables.
Those are derived from sugar? We're deriving vitamins from sugar? That's interesting. I didn't think that's how we got vitamins. I wonder what the truth to that is. Like, again, I want an explanation behind these claims. Like, that's always what it is. Like, these people make the wildest claims and then, like, never back it up. So I'm curious. Like, so do we actually make vitamins using sugars that we extracted from plants? I'm curious.
Derived from sugar give man his vitamins.
Derived from sugar give man his vitamins. Like, that's a pretty clear statement. Like, I want an example. Like, can somebody in the comments answer this for me and then give me an example of this happening, please? I'll read it. I swear to God, I'll read it.
Not only the well-known leafy vegetables, but fruits are important natural sources of vitamins. By other transformations, plant sugar goes to form many useful drugs.
Really? So we're using plant sugar to make useful drugs? Like, I'm out of my comfort zone now. Like, I don't know if that's possible. I guess I just didn't know if that was possible or not. I guess it is. I guess I'm learning that we do that.
In cinchona bark comes quinine.
Hang on, I knew that though. From what bark? Oh, what bark? I should know what quinine comes from. I'm surprised we're learning about quinine, but like, what? It comes from a very specific plant from South America, doesn't it? I gotta go skip back. Now I need to know what plant quinine comes from again. I made a whole video where I talked about this. I don't even remember what video, but I remember mentioning quinine in a video of mine. And I specifically remember showing the visual of the plant that is used to make quinine. So I should remember this. I really should. I'm honestly a little disappointed I don't, but let's just learn then.
Among the other drugs which...
Hang on, this little vial says digital. That's interesting. I'm curious what the connotation behind digital on this vial of white powder means.
form many useful drugs. From cinchona bark comes...
Cinchona. I feel like... No, I still don't recognize that. I feel like it has a more common, like, popular name.
Quinine. Among the other drugs which come from plants are digitalis.
Digitalis? Okay, so they are giving us examples. Thank you. This is exactly what I asked for. Okay, so other drugs that are made from plant sugars are P-digital? That is not what I would expect a drug to be named. But is anyone familiar with this drug, P. digitalis? I don't even know what that means. Is that a specific plant? Is that like the species name, or is that like the name of the drug? I can't tell.
Vitalis, belladonna.
Belladonna? Okay, that I feel like belladonna is like an ingredient to make a potion in like RuneScape. Like I feel like that's how I know the term belladonna. So I can believe that we're putting these in vials in this world as well. Like I actually like that. Can somebody also tell me what you use belladonna for in RuneScape? I'm telling you, you use belladonna to make some potion in RuneScape. And this is what? Stitch sulfur? Hang on, I gotta go back. They're not explaining what these drugs do though. Like, are they just random white powders? Like, what's the application of P digital?
Belladonna and strychnine.
Strychnine sulfur. I don't know. I don't know what these drugs are. Yeah, can somebody explain to me like all of those drugs and what they do and where they come from? Like, I'd really appreciate it.
And still other things may happen, for the plant is an able chemist. The color and
For the plant is an able chemist. Another little like poetic verse right there for you guys.
fragrance of flowers are made in the plant from sugars.
I feel like I should have known that. Like the plants, I mean, I guess the sugar is just like the energy of the plant. So pretty much everything in the plant is made using sugars one way or the other.
The banana of the tropics and warmer subtropics, which takes the place of bread and potatoes in the native diet,
Is that true? The banana takes the place of bread and potatoes in the native diet? See, that's wild because I feel like is that like their carb then? I did not in my head hold like bread and potatoes as equivalent to bananas. Like bananas to me are still something that's like maybe a little healthy because it's a fruit, but like bread and I don't equate those two, I guess, is all I'm trying to say. That is interesting though. If people in I guess in banana land use bananas instead of potatoes or bread. I can see them using plantains. Maybe that's what he meant because they do use plantains for that exact purpose actually. Not bananas, but plantains or plátanos.
rich in sugars.
Maybe these are plantains. These kind of look more like plantains, or at least they look like unripe bananas.
The pineapple, too, has a high sugar content.
Dude, the pineapple might be like the most delicious fruit of all time. Like, I'll say it. Like a fresh pineapple, there's nothing better.
Of the 350,000 known kinds of plants, man places chief reliance on only two, the sugar cane and the sugar beet. For the sugar...
Huh, that's interesting. Man places chief reliance on only two. That's funny how, like, the only reliance that we have on plants is for sugar. Not for food or anything, just for sugar.
Sugar he directly consumes.
So hang on, sugar cane and sugar beet. See, I've never had either raw, but like, can you just eat them raw? Are they like as sugary sweet as pineapple? You know, like, is there like another world where pineapples are harvested for sugar instead of sugar cane? I mean, if that were the case, they'd probably be called like sugar apples or something, which is not a bad name for them, honestly, but I'm curious. I'm curious if sugar cane and sugar beet actually tastes sweet.
Sugar cane thrives in the warm, humid climate of tropical and...
I feel like I've seen people actually eating raw sugar cane, so I bet it is a little sweet. But what about sugar beet, you know? Like, can you just eat this?
subtropical areas. Its cultivation dates back centuries before the time of Christ, and Columbus introduced it to the New World.
Hang on, so people were cultivating sugar before Christ? That's interesting. I didn't know that. I don't know why I would know that, but like, that's interesting that people were farming sugar cane. That like, I wonder if they were farming it for this exact reason too, or if they had other methods of extracting the sugar from it.
The sugar formed in the leaves
And what's so funny about sugarcane is it's like really the least spectacular looking plant of all time. Like it really just looks like tall grass. Like you wouldn't imagine like the most delicious taste like humanly possible would come out of this plant, you know? Like this, it doesn't even look like it has a flavor, you know? Like like it doesn't look like it's sugar flavored.
is stored in the stalk of the cane.
See, like, is that little droplet, like, does that taste like sugar water? Like, I'm so curious now. You know what? I've been seeing sugarcane at my local grocery store. Maybe I'll pick up some and try it now. Dang, there's nothing quite like the industrialized hellscape of 1946 too. Like the giant factory, like smokestacks. Like what a hard transition to make from all these sugary sweet plants to a factory.
Sugar beets are grown in virtually all countries which have a temperate climate.
Sugar beets are grown in virtually all countries that have a temperate climate. That's funny. I wonder, I mean, that probably is true. It's funny to think that, like, yeah, there are two forms of, like, sugar extraction. Like, you either get your sugar from beets or from cane. And it's just like, it's a geographic distribution as to what you would originally get your sugar from.
In the beet, the sugar formed in the leaves is stored in the long white root.
Oh, wow, that's interesting. I didn't actually know what a sugar beet looked like underground. So I guess they look like a white carrot, which I guess it's just a root or a tuber, right? So that makes sense.
Trains and trucks bring the beets from field to factory.
But alright, so can I eat a sugar beet? Is it like even soft enough for me to bite into, or do you have to like refine it somehow? I just like, can you bite into a sugar beet? You know, like that's what I want to know. Like, why aren't we just eating these things as like fruit, you know?
Where sugar is extracted from them.
They're probably not good raw. They're probably like too hard, too tough, and like not sweet enough. But I don't know, maybe I'll have to find a sugar beet too. It is cool seeing like the industrialized agriculture. So we just watched The Wheat Farmer. So this is already like we're already familiar with this sort of industrialized agriculture.
The food which the green plants
Man, if there's a combine in this, let me tell you, I'll know it.
make is their direct source of energy. It enables grasses to grow tall as trees, like the bamboos. In some countries, they attain a height of more than 100 feet.
See, this is a little frustrating though, because bamboos aren't native to America, so like these bamboos are invasive, or at least I'm pretty sure these bamboos are invasive. Again, I don't know exactly what bamboos these are, but I'm here to tell you that these are probably invasive. Unless that was filmed like in Asia somewhere, but I doubt it.
The strange saguaro, the giant cactus of the Arizona desert, in the place of leaves which give off water, has developed in its trunk organs to store water.
There's some very interesting shots of cacti though. Like these are, like look at this one. This one has like tusks, like a mammoth or something. That's funny.
Having no leaves, this adaptable plant makes its food in the tough skin.
You know, I guess I never really thought about that either. So cacti don't have leaves, so they perform photosynthesis in their like bark or their outer layer, their epidermis maybe not, I don't know. But like, that's interesting. That's just another thing that I never really thought about before. So that makes sense because the cactus's like skin, I guess, their epidermis is green. So I guess that is their photosynthetic surface. That's interesting.
Like the saguaro, the smaller cacti grow sharp spines. These spines protect them from animals which would eat them for the moisture they store.
Yeah, this must be like the most bizarre evolutionary adaptation for a plant to ever undergo. It's just to be absolutely covered in needles. Like a very effective evolutionary path, I must imagine. Like I can't imagine anything even trying to eat this, but like how bizarre is it also that like plants are just covered in needles like this? Like the more you look at it, the more you're like, wow, it's actually pretty strange. It's also weird, I learned this recently, but there aren't really native cacti in like the old world, like Asia, Europe, or Africa. Like there are now, they've been introduced. Prickly pear is like crazy invasive across Africa, but like there's no native cacti, which is interesting. It's very, very specifically North American flora right here.
The energy of some plants is sufficient to move rocks.
Yeah, these roots are reminding me of the temples of Angkor Wat. I wonder what sort of trees and what sort of like rock formation these are growing into. Because like if they're anything like Angkor Wat, then there's something else interesting happening here. These look like just a rock face though. But I feel like everyone in their minds right now is thinking the ruins of Angkor Wat, just looking at these roots.
And this energy can be destructive to other plants. The strangling fig, wrapping itself around the great live oak, may finally kill the older tree.
It actually is bizarre. Like it's standing on so many little like legs. Like this is a bizarre sort of plant. Very tall. Like, we have been looking down for a long time now. Like, that is a very tall plant right there. I mean, I guess it's a tree, but like, for the way that it grows, that's so fascinating. Like, look at that. It's just like a lump of like vegetable matter on top of this tree.
The wood of these great trees is derived from the sugars made in the leaves. This food, then, is a building material as well as a source of energy. It was a building material for the oldest and largest of living things, the giant sequoias of California, 4,000 years old and more.
Yeah, what's funny is these trees are definitely still alive. Well, at least if they haven't been cut down yet. But like, if nothing bad happened to these trees, no fires or anything, or even if there were fires, like these trees are still alive today. Like these trees were alive like 1,000 years before any of us were born, and they will still be alive after all of us die.
And 300 feet high.
Yeah, this tree right here is older than like the nation of America.
Here, reconstructed with great skill, are the remains of animals which lived in past ages.
Wow, see, this is interesting. I did not expect us to be looking at like fossils in a program called The Gift of Green. So this is really cool. This is like a little bonus almost.
Many millions of years ago, long before man inhabited the earth. As animals live from plants today, these prehistoric monsters too derived their sustenance from plants.
That is crazy that like they really would just eat plants, like, and different plants. I think that's what's interesting is like the entire diet of these animals was still plants. Well, maybe not this T-Rex skull, but like most dinosaurs were herbivorous, and like they were just eating plants that like don't exist on Earth anymore, or aren't the dominant type of plant on Earth anymore. Like flowering angiosperms conquered the Earth only after the dinosaurs were already eradicated. So the plants that we have today are actually not very similar to the plants that dinosaurs were eating. I mean, there are still some like conifers and ferns and whatnot. They're just not the dominant plant type anymore. Like if you let loose a dinosaur in today's world, they probably would not be able to eat like most of the plants available.
Then, as today, even the carnivorous animals eating the flesh.
Oh dang, I love the old artistic rendering of a dinosaur. I mean, this isn't too inaccurate. Maybe the one in the background is a little inaccurate, but like I love these old drawings too.
Flesh of other animals which lived on plants, in the last analysis, were dependent on.
Dude, hang on, look at these guys. What? Oh man, I feel like these aren't pachycephalosaurs. What are these guys? These are some sort of hadrosaur, right? Man, but they're the duck-billed hadrosaurs. I don't forgot what those are called. There are so many different types of dinosaur, but like these are at least closely related to hadrosaurs. I don't know if they are hadrosaurs or what type of hadrosaurs they are, but like they're not theropods, that's for sure.
The plants for their food.
And then we got some sauropods. I would not know anything about these if it weren't for the video on the biogeography of dinosaurs that I made on Atlas Pro. Like, that's the reason I know anything about dinosaurs, is that one video. Oh, now we got a Triceratops or a Ceratopsian. Interesting. Yeah, that might not be a Triceratops. That might just be another Ceratopsian.
And here, embedded in rock, are the fossils of plants which lived in those remote ages.
Oh, this is what I was saying. Like, these are actually different sorts of plants than what are alive now. That's cool, though. That's cool that we have the fossils and that we're getting to see them here.
These prehistoric plants were once green and made their own food, the basic food of nature, just as the green plants do today.
Yeah, I guess that's fair. Like, even though the plants were different, like, they were functionally the same. They were still undergoing photosynthesis for the creation of sugars. You know, I guess that is a fair statement.
But they are more than relics of past ages. From such plant remains, buried in the earth for millions of years, come the world's sources of industrial power.
Oh, okay, so now it's going full circle. So the sugars that the ancient plants made back during the dinosaurs got stored and turned into fossil fuels. That's the claim that we're trying to make, which is interesting. I don't know if it's really plants that made the sugars that turned into oil. I feel like that's more single-celled bacteriums and whatnot, but I guess it could have been plants as well. Though I guess it was like the body parts of the plants that became coal. So maybe that's what they're talking about.
Coal is one of
Oh,
these.
they are talking about coal. Okay, so yeah. They were talking about how, like, during the Carboniferous period, or I think it was the Carboniferous period, how the plant bodies could not be broken down because there weren't actually bacteria capable of breaking down plant matter yet. So all that plant matter that did die just got preserved underground. So all those plant sugars that were produced were also preserved in the ground, and that's what we now burn to power our cars. Or I guess power our factories, not gasoline, but coal.
These sources of energy. Coal is a fossil fuel found in the Earth's crust and formed of plants that lived ages ago. Petroleum is the other source.
Yeah, see, petroleum is not plants. Petroleum is like microscopic organisms piled onto the seafloor after ages.
Oil in the earth originated from plants and animals, and, like coal, it represents the energy from the sun, stored in sugars made by green plants, which grew millions and millions of years ago.
That is true. Like, all the energy in oil is just like a transformation of the sun's energy that arrived here on Earth like millions of years ago. I feel like the more you think about it, the crazier that is. But I guess like even microscopic like bacteria with chlorophyll still count as plants in this regard. So I wasn't wrong. We have a little bit of a disagreement.
This stored energy is set free when coal and oil burn. Man uses it to drive his great industries.
I love these shots of the great industries. Like, to me, this looks like an industrial hellscape. But I guess to the people back then, this was like a really impressive feat of engineering. The fact that you had like industrial wastelands like this. Just like all the smoke rising up. Like, this place looks just horrendous to me. But I guess back then it was cool.
To heat his buildings.
Oh wow, look at these skyscrapers. I was not expecting like office buildings with this sort of like lighting and everything. 1946, we still had skyscrapers. That's not wow. I mean, I guess what? The Empire State Building was built in 35, so I guess it makes sense that we had skyscrapers. I wasn't expecting something so modern looking.
To light his world at night. Power his local.
It's kind of crazy how that's what we're talking about now. Like, this is a program called Gift of Green, and we're learning about how we power like lights in a city.
Locomotion by land.
Like, I guess it is related, right? Like, I get it, right? Like, the green things from a million years ago became our energy for buildings now. It's just like, I don't know. It's a weird direction for us to have gone in. I thought we were just going to be learning about plants this whole time, but not a bad direction, just interesting. Again, you have to put yourself in the shoes of like a kid in middle school being forced to watch this. Like, would this really have been interesting? Maybe. I think it would have been, but like, I think it's not keeping on the same path. It's like, yeah, we learned about plants for a little, but now we're learning about trains.
By sea. By air. All of this, the power of our complex age, we owe to the green plants.
You know, I am curious now, like, how many plants did it take to make the fuel to fly one plane? You know, like, what's the actual, like, volumetric and, like, temporal commitment to the fuel that flew that plane? You know, like, how much photosynthesis did it take to fly that plane?
Green plants and what they do with water and air in the sunlight. Green leaves and the wonder worker in them. The sun-trapped chlorophyll, the sun's energy caught and fixed in a gleaming sugar crystal. Green plants' gift to the living world. Food of nature, food of man.
Again, the language they use, like, it feels propagandistic to be like praising like a sugar crystal, you know? Like, it's so extreme. Like, they were so like emotional about like their praisal of like random things in the world.
Source of his development and power.
Like, I mean, I guess it's true, right? Source of man's development and power. Like, yeah, photosynthesis kind of makes the world go round for us. It's just, I don't know, the way they use language in this is so like, so bombastic.
Through the ages.
And again, the program is called Gift of Green, and the final shot, the final shot of the thing that we're celebrating the most is not like a leaf or chlorophyll, it's a crystal of sugar. You know, like it's just like, why isn't this a leaf? Why aren't we talking about a leaf right now? But whatever. Are there any credits? Okay, so it was a Robert Flaherty production. They didn't mention that at the beginning, but I did. So I'm glad it did end up being true. Photographed by Boris Kaufman, Richard Leacock, and Carl Pryor Jr. Interesting. I guess good work to these guys. That must have been a fun trip to the botanical garden for them. Okay, what else? The acknowledgements, Dr. Alan K. White for original time-lapse photography. So wow, they really had to find the time-lapse. They had to go to a specific person for that time-lapse. I wonder if that would be crazy if this was the same guy who made the time-lapse footage for the other program we watched. I don't know, but shout out to him. He really did some impressive photography. And then we have the Department of the Interior for permission to photograph scenes in the Sequoia National Park. Okay, cool. American Museum of Natural History for permission to photograph plant and animal fossils in the museum. Is this the one in New York, or is this in DC? Oh, it's probably the one in DC. It makes sense for you to go to the New York Museum of Natural History if you're already at the New York Botanical Gardens, you know? I don't know. But I'm pretty sure the American Museum, that means it's in DC, which I've also been to, so I don't know. All right, anything else? No, that was it. So that was The Gift of Green. Another enjoyable watch. I feel like we did learn a lot about plants. I don't know if we learned a lot. We definitely reviewed a lot. Or at least I reviewed a lot. I hope you guys learned a lot, though. The only questionable part is, I guess, like the last 5 minutes when we just spoke about nothing even related to plants. I guess it was related to plants, but it didn't feel very related to plants. Like the fact that we spent the last 3 minutes talking about fossil fuels, I don't know. Like, I guess I get it, right? Like fossil fuels and photosynthesis are like one and the same. And I guess that is like a very interesting observation for people to make, especially back then, to understand where this oil came from. I guess that is like pertinent information, especially for the time. It felt sort of out of place with the rest of the information in this. But overall, very enjoyable. I think this was a good watch. I don't think there were any boring parts. I think this is like the perfect program, really. This should have been the first program I watched for the Green Channel. You know, like this would have been a great introduction to like the concept of green, which sounds silly, but if you guys know what I'm talking about, you'll agree. Yeah, overall, enjoyable. I'm scrolling through it, trying to find other stuff to talk about, but I really don't think there is. I really think this was just a very enjoyable watch with nothing else to really complain about. So I guess I'll say, if you enjoyed watching and would like to help support me and this channel, you can follow the link in the description that'll take you over to the Internet Archive. The Internet Archive is where I get all these old programs from. So if you want to help support me, you can leave them a donation. And with that, I think we're ready to cut to black.